It's a real pleasure to introduce her. She's a colleague of us from a long time now. For several years we have been collaborating in different research projects and also in different journal articles. And well, she's also a professor or associate professor or whatever here in this university, at the University of Catalonia, from a long time now. And actually, currently, she's sharing a course together with Laura, and it's the second year now that they are sharing a course. I hope the experience is good for all of them. And she's also helping us in some research projects. So thanks, Eva, for being here today. Okay?
Thank you. Okay, thank you for your introduction, and thank you for the invitation. It's always a pleasure to be here. So my talk is related to the optimization problems in port terminals related to the container yards. So this is a picture of the port of Valencia with the yard container and the vessels. So the containers has to be loaded or unloaded from or to the vessels. So this is the outline of the presentation. First, a short introduction of my research group and the problem I'm working in now, the yard crane scheduling problem, the approaches we are developing, we are working now, and the future research. So the research group is the SOA group, Sistemas de Optimización Aplicada. We are inside the Instituto Tecnológico de Informática at Universitat Politècnica de València. We are 5 professors. Rubén Ruiz is the leader, the supervisor of the group. I think you know Rubén. And then Fulgencia Villa and myself, we are specifically working in the yard crane scheduling problem. And moreover, there are 5 more people working at the institute. So, and this is our website. We can check. Latest news, the PhD of Sarah Hatami, your colleague. So we have several projects and products. Okay, we have several projects funded by Spanish government or Valencian government. And now we are working in this project. It's optimization of scheduling problems in container yards. We just started this year, 2006, for 3 years. And we also work in some products for companies. We have 3 softwares. Routing Maps is a software for route optimization, and Sequen is a software for production scheduling and optimization, and ForPlanner is for port forecasting for demands and production planning. So these people who are working in the institute, they are mainly working in these 3 products, the products for companies. So our objectives as a research group are, on one hand, the application of quantitative methods to real problems. We are always looking for real problems. And on the other hand, to advance in the state-of-the-art techniques for these problems. We have been working the last 10 years mainly in production scheduling problems funded by Spanish government, Valencian government through several projects, and some private companies also. Okay, so now we change our topic slightly, and we are now working in optimization of scheduling problems, but in container yards. Now we have a project also funded by the Spanish Ministry of Economy and Competitiveness, and we are going to study 3 problems inside the yard container. And the first one is the pre-marshalling problem. Is before the vessel arrives at the port, the containers in the yard can be relocated in order to in the same order that then they will be loaded or unloaded from the vessel. So you can relocate the containers, and then you can minimize the number of non-productive movements of the crane. The reshuffling problem is when once the vessel is already loading or unloading the containers, you can also relocate some containers at the same time. And finally, the yard crane scheduling problem, we want to obtain a sequence for the crane in order to extract the containers from the yard to the vessel, or unload the containers from the vessel to the yard. So we want to optimize the sequence movements for the crane. So on the other hand, the other university in Valencia, Universitat de València, they are already working in this type of problems, in port containers problems. They already have a project funded also by the Spanish government. And so we are working together with two professors from the Universitat de València, Ramon Álvarez and José Manuel Belenguer, and my colleague Fulgencia Villa and myself. We are working together specifically in the yard crane scheduling problem. So to introduce the problem, we have to check the evolution and forecast of the traffic of containers around the world during the last few years. So in the green line, we can see the optimistic forecast, and the blue line is the pessimistic forecast, and the red line is the average. So now we are more or less at this point, 2016, and it seems that real values are closer to the optimistic line. So it means that in a few years, 1,000 million of containers, the traffic of containers will arrive to 1,000 million around the world. So on the other hand, we can see the vessel's evolution. We can see in the red line is the average number of vessels per country each year. So we can see in the last few years, the number of vessels did not increase. And the green line is the average size of the vessel. So we can see that there are no more vessels per country, but these vessels are much larger than before. So the consequences of this are that port infrastructures has been updated to the arrival of these new vessels with this size. Berth areas, quay cranes, drafts, and so on. But for the container yard, it's not so easy, because the space has to be gained to the sea. So it means that the cost is really high, and also the impact of the environment. So the solution we propose is optimization for this container yard. If you optimize all the operations in the container yard, you can improve your movements and everything. You can work better. So the two possible configurations of a yard container are, on one hand, the Asian configuration and the European. The main differences are how the blocks of containers are located in the yard. This is for Asian configuration, and this European. Each rectangle is a block of containers. And the main difference is that in the Asian configuration, trucks trucks can travel among the blocks. So they can stop and the crane delivers or picks the container up from the truck or to the truck. And in the European configuration, trucks are not allowed to travel among the blocks. There are some inputs, outputs points, so the truck is located in one of the inputs, outputs points, and the crane is moving to this point to deliver or to pick up the container. So this is in more detail a block container structure that is one of these rectangles. And the notation we usually used is the number of rows. Each block has a number of rows, a number of bays, and a number of tiers. This is the yard crane. So the yard crane can move from one side to the other side, from input-output points on the land sea or input-output points on the sea side. And in our case, our problem, I think we spent maybe 3 or 4 months thinking about the problem we wanted to consider. We consider the European configuration, just one block and one crane in each block. So following this picture, just one of the blocks with one crane. It's a simple case to start with the problem because it's a very complex problem. But we are going to consider the input-output congestion. That means that when a container arrives at the port, you have to assign an input-output point. Or when a truck arrives, you have to assign an input-output. And maybe there are no available inputs-outputs. So you have to take into account the availability of the inputs, outputs. Our objective is minimize the total weighted delay. Delay respect to some time parameters we will see later, depending on the operation, and also respect to this availability of the inputs outputs. If the container arrives and there is no available input output, the container has to wait. So the delay increases if the container has to wait for an input output. We are going to consider reshuffling and not like an optimization problem, just like a constant. It means that if I have to extract a container from the yard and this container is not on the top of the block, I have to move containers above. So I have to spend an amount of time. And this amount of time we are going to consider as a constant time. And we know the container request or the load and unload plan is known in advance in order to schedule the movements of the crane. So the container operations that the crane can carry out are there are four types of operations. Type 1 is storage from sea when the container arrives, and from the vessel has to be stored inside the yard. Type 2 is the same, but from land. The truck arrives and the container has to be stored from the truck to the yard. Types 3 and 4 are the opposite operation, retrieval to sea or retrieval to land. When the container is inside the yard and you have to pick up the container and to go out to the vessel or to a truck. So type 1, storage from sea, it's working, the container arrives at the port, and then from the berth or the quay crane, with an automated vehicle, the container is carried to an input-output point. And the crane moves to this point, and the container is stored inside the yard. In this case, we know our parameters are the release date of the container, so the container can't be stored if it didn't arrive yet. The final position where the container is stored is known in advance. I know where the container is going to be stored, but I have to assign an input-output point. I don't know the input-output. Okay? So storage from land is the same operation, but on the other side. The truck arrives, and from the truck to the yard. We know also the release date of the container. The final position is also known, and the truck needs an input-output to unload the container. Type 3 is retrieval to sea. It's the opposite operation. In this case, the crane has to go to the position where the container is, and the container is moving to the input-output, and from the input-output to the quay crane and to the vessel. So in this case, we have a due date because the vessel is, has an arrival time and a due date to going out from the port. So related to the due date, the container can be computed the earliness or tardiness depending on the time you extract the container. The initial position is known, this position, where the crane has to go to pick up the container. Is it possible to have a reshuffling if the container is not on the top of the block? And we have to assign an input-output for the container. And type 4 is very similar, but on the other side to land. In this case, the crane is going to pick up the container inside the yard and is moving to the truck. In this case, we have a truck arrival time, because if the truck is not here, you can't extract the container. The initial position is also known. The crane knows where it has to go to pick up the container. We also have a possible reshuffling, and like all the movements, we have to assign an input-output. So several authors are already working in this kind of problems. We have several references here, but most of them are focused on exact methods for the problem, and they do not consider the input-output congestion. They assume that there is always an available input-output. So we want to consider this congestion because we think it's our main contribution to the problem. Because in the literature until now, they don't consider this constraint. So our approaches, before to introduce our approaches, we need to know the input data we need to solve the problem. We need the yard configuration. The yard configuration is the number of rows or bays of tiers, the number of inputs, outputs on each side, the number of container requests, how many containers I have to pick up or to load or unload, the speed of the crane in order to compute the movements or the distance between the containers. The reshuffling time, but in this case, as I said before, is like a constant. We are not considering the reshuffling as an optimization problem. The initial position of the crane, we need to know where the crane is at the beginning before the first movement. And we need to know the details of the container request, the type of the operation, type 1, 2, 3, 4, and the initial position, the final position, and so on. So we generated, for the moment, 3 sets of instances, small, medium, and large. Small with this amount of container requests, 5, 10, and 15, medium 20, 30, and 40, and large until 200 container requests. Okay, our approaches. First thing we developed was a mathematical model, but the mathematical model is really complex, and especially because of the input-outputs assignment, because you have to consider the assignment of the input-output inside the mathematical model, and we have to assign, theoretically, the optimal input-output according to the position of the container. So it's really complex. So it's only able to solve instances with 5 container requests. So it's not very useful until now. Now we are working in constructive heuristics in order to solve instances, larger instances. According to an initial order, we are based on different parameters, time parameters, due dates, earliness, release dates, and so on, or the priorities of the containers, and so on. And we are working in developing a fast local search, because we want to allow movements in the sequence of the crane, but in a fast way, because we want to change the sequence and to evaluate again all the objective function, but in fast, because if not, we can do movements. And from these constructive heuristics, starting from these heuristics, we are going to develop some meta-heuristics like iterative greedy or genetic algorithm, and so on. But actually, we are now at this point, constructive heuristics. So the future research is almost everything. It's not future, it's present research, indeed. We are improving the model in order to obtain better results, because 5 container requests is almost nothing. And we are working hard in the heuristics and meta-heuristics methods. And in the future, we would like to increase the problem configuration, considering several blocks instead of 1 block, or several cranes per block, and so on. So that's all. Thank you for your attention. So if you have any questions or comments.
Any questions?
How robust is your system for delays of the tracks?
How? Sorry?
How robust is your system for delays of the tracks? For example, as input data you have the time the track is coming,
Yes.
well, but probably, I don't know, in Barcelona it's very common that tracks are delayed.
Yes.
How robust is your algorithm if tracks are delayed? Because
we are working still in the algorithm, so if the track is delayed, so the objective function value will be increased, because you will have if you have a theoretical arrival time and the track is delayed, so the delay is computed respect to this arrival time, theoretical arrival time. So, or you can reschedule everything, updating the data. If the arrival time of the track is not going to be on this time, is in the future, so you can change maybe the parameter.
But you have to recompute the...
Yes. Mm-hmm.
So, taking into account your answer, it means that you are solving the problem every time from a deterministic point of view, the optimization, or are you trying to solve the problem from some kind of random times?
No. Now it's deterministic. Now it's deterministic.
Yeah. So
until
I
now,
guess
yes.
in your pocket or on your table, you have the random
Yes.
times already.
Yes, you are right.
Because the question is quite natural.
Yes.
Because
Everything is delayed in the real
and you are
life.
assuming also right now some kind of constant time for each one of these times, and depending on the place on the stock that the package is, the time is not exactly the same in terms of time and also in terms of cost, because you are minimizing right now the number of movements, but if you try also to minimize the costs associated to, then there is also this kind of differences depending on the height where the blocks are located.
Yes, we are working in this problem. We just started, so we have a lot of work to do yet.
Any other question? Okay, so more or less in the same line as Carles and Tony, Javier Panadero just sent me an email saying that he and Laura were interested in analyzing this problem from the stochastic point of view, and therefore, in particular, according to Javier, he thinks that one of the points where the stochasticity can play a relevant role is in the reshuffling.
The reshuffling.
Because this might be a very interesting source of randomness, right?
Yes.
Because you don't know, in principle, in the math, you don't know how much time will it take to reshuffle all the containers, depending on the...
Yes, the other two problems, the pre-marshalling and reshuffling, the rest of people from the group, theoretically they are working in this problem, but I think they didn't start yet.
So well, this is an invitation, so if you think it could be interesting, Javier and Laura just sent me an email about that.
Yes, absolutely, because these problems are of natural stochastic, because you can't know exactly when the truck arrives to the system, so it's difficult. So it's okay. If you are interested. Javier. So.
Any other question?
I would like to ask.
Yes.
And you always focus on practical problems, which are real life problems. And I would like to know if you know how they solve this problem, the companies, if you are able to compare.
I think that the ports in general are like a very closed system. They don't like if you ask a lot of questions, and so now I think they don't have any optimization system to solve the problem.
So the companies are interested in this?
Who knows? There are a lot of people related to all the port, the trucks, and I don't know the names in English, the estibadores, and portuarios and everything.
Maybe Jessica can provide more information since she comes from a group, a research group in which they have been working these problems, and also because she's her
Yes.
family is one of the owners of a very big.
I could like. I know, but I have visited different ports, and some of them explain that they have some software that indicates exactly where is a container or where to put or locate a container. But, for example, certain cranes cannot see what's happened behind a stack, and sometimes the program says, put your container here, but in the reality, the crane cannot because she cannot. The crane cannot see what's
Yes.
happening behind. So sometimes they only change manually the position and this kind of thing. There are many things that they do by hand.
Yes. Yes, I guess.
Are you aware of if there are significant differences between the way we deal with these problems in Spain and, for instance, in other countries like I'm thinking now in the Hamburg
Yes.
port or
Mhm.
I don't know, Rotterdam port or in Asia's port? Do you think there are significant differences in terms of the technology and the methodologies we use?
I think yes. I just saw some videos in YouTube from Hamburg port or Rotterdam, and I think they are much more automated than here. Yes, and I think they used to work with a lot of people from the University. Stefan Boss, and in Hamburg, he's always working in this kind of problems, optimization problems.
I want to say that I'm really new in this kind of approaches and this type of problems, but I'm really surprised that behind this amount of money that the ports are moving around the world, there is not some kind of more improved software that someone just proposing some positions to be covered.
Yes, it's true.
In a hidden way, because you said that sometimes the solution is not available for the machine. Okay. It sounds quite incredible. We are
Yes.
arriving right now as the first investigators working with that.
I think that's not the case in Spain. But I also see
Yes,
some videos in Germany or the Hamburg port.
Maybe in other countries it's different.
Yeah, but the girl or the women in Madrid that was working with you in the University of La Laguna, they show some new really improvements on this line. Related in a different way,
Yes,
but
they-
more or less related with the same type of
Yes,
problem.
they have been working in the pre-marshalling problem,
Mhm.
and they have several articles on this problem. Belén and Christopher Esposito is a PhD student, and they are, I think, more focused on this problem, the pre-marshalling.
I really want to say something else.
Can you speak about some types of the retrieval, sea, land, some four types? Do you consider each of them separately in the mathematical model, or?
Yes, because inputs outputs, you have an amount of inputs outputs on the sea side, a different amount of inputs outputs on the land side. So depending on the type of operation, you have to move to the sea side or the land side. So it's separate. If you want, I have the mathematical model.
My view is that it would be relatively easy to develop like a simple heuristic, consultative heuristic, not a method heuristic, maybe it would take more time, but a simple heuristic. And then add this layer about the simulation to take into account the stochasticity in the model. What do you think about that? Do you think that would be an interesting article for journals?
With stochastic terms?
But
I think that
with the simple heuristic,
maybe. I didn't see anything about stochastic. Okay. This is the long version of the presentation. So actually, we have two mathematical models. One is related to, it's like the crane is a vehicle and you have to construct the route of the vehicle. And the other one is from the point of view of scheduling, because the crane is like a bottleneck, it's like a machine. And you have to sequence all the containers in the crane. So we have a lot of parameters for the mathematical models. The inputs, outputs, sorry, it's in Spanish because this is a different presentation. The inputs, outputs on the sea side or land side. So there are a lot of parameters, the release time, due date, etc. All these parameters, I think we remove now from the model because they are like service times. When the crane, for example, delivers a container, you need maybe 2-3 minutes until the trucks left the block. So all these parameters are to model these times, service times, the minimum time between two operations at the same input-output point. So all the variables regarding the movements of the crane. So we have the objective function. This is the objective function, a lot of additions. So it's the delay with respect to the release time. If the container is type 1 or 2, this type 1 is when it arrives from sea, from the vessel to the container yard, and type 2 is when it arrives from land, from the truck to the yard container. And this variable, TGF, is the final time of the crane for this container. So you are computing the delay respect when the crane ends with this container respect to the arrival time of the container to the system. So for type 3, we have a due date, so we can have a delay with respect to this due date. And for type 4 is the delay respect to the arrival of the truck. So this is the objective function. And the second line is delay respect to the if you don't assign an input-output to the container, because all of them are occupied. So there is no an empty input-output. You have to wait until an input-output is free. So you have to add this delay to the objective function. So restrictions, there are a lot, of course, and this is all the constraints of the model. I'm not going to detail all of them, but we have maybe some results. This is the second model. It's a model based on scheduling, because the crane is like a bottleneck. If you have one machine, it's a single machine problem. And you have to sequence all the containers in the machine, the crane. This is a classic problem in scheduling, so you can adapt the model, the one machine model, to this. But this model works even worse than the previous one. So they are really slow. This is all the input data, and this is the generator of instances. If I want to generate instances for the problem, the number of containers, all the configuration of the yard, etc. And here we have some results for 5 containers. And we have 10 instances with 5 containers, with this number of variables, this number of constraints. This is the objective function value and the time in seconds to solve the problem. So when you pass from 5 containers to 10, it is dead, the model, till now. But we are working in improving the model to get better results.
When you show the objective function, it seems to, so you are, I guess you are assuming that the penalty term is linear, right?
Yes.
Because it's a linear objective function. So
Yes.
Is it a realistic assumption? So in other words, would it be more realistic to assume that this term is non-linear and therefore you have a non-smooth optimization problem there?
Maybe. We are considering a linear objective function. So it's just the penalization respect to the arrival time, the due date, or the not assignment of an input-output. But each container has a weight, it's a weighted total delay. So each container can have a weight or priority or so. Oh, this is okay. This part is this variable is the final time of the crane for this container. Final time of the crane, but this variable is not the final time. It's the initial time of occupation of the input-output. So depending on the term, the variable is different. This is because this is type 3. Type 3 is that you have to extract from the yard outside. So you are computing this delay respect to the due date, but according to when you the initial time that you occupied the input-output. So this is and for type 4 is extract the container, but from the yard to the truck, you are computing respect to the final occupation time for the input-output. Okay? So depending on the term, the variable is different. Yes?
Solving the mathematical model, the biggest one, you mentioned that 500. What is the time? The time it was 6, 7 maximum.
Yes.
If you try with more bigger instances,
Yes, with 10 instances, with 10 containers, after a long time, I don't remember how much time, but after several hours, it didn't solve the problem. So there are a lot of variables and constraints and everything, so the problem with 10 containers is too much complex. So, but I think we are going to improve. Our colleagues from Universitat de València, they are going to improve the model. Because my colleague Fulgencia Villa and myself, we are working in heuristics and they are working in the mathematical model. So, more comments, questions?
Thank you very much.
Thank you.